Thanks everybody for coming to my talk. I know it's kind of towards the end of the day, and it's been a long day of really great content. I actually just want to take a second to just thank just the Midwest.io staff, all the other speakers. The content here has been phenomenal. I had the privilege of being here last year, not as a speaker, but as an attendee. I loved it so much. I was really inspired by a lot of the other talks that I saw. And it's actually part of why I'm here speaking today. So let's just give everybody a big hand for putting on such an amazing conference real quick. And conveniently, I don't know if you noticed, but I took a picture of you clapping. So in the event that this talk sucks, I can prove that it didn't when anybody asks me how it went. So my name's Chris. I work for a company called Carbon 5. I also have these amazing cat stickers that say the future is meow with a cat wearing a VR headset. So if you want one of those, come up and find me. Also, they say you shouldn't put a graph at the beginning of your talk, but I did. And this is happiness with a sticker and without a sticker. So if you come get me, you will have more happiness, clearly. So I want to start by just getting something out of the way. And I want to let you know, I am not a data scientist. I don't spend my time looking at math. I have a very cursory understanding of machine learning. Safia gave a great talk yesterday about genetic algorithms, and that's not what I do. She's good at that. I am not. I'm just a programmer standing in front of some data, asking it some questions, and wanting to get some answers. And I do that a lot by just visualizing the data. By being able to sort of take a view of it, I can actually start to suss out those things and kind of make up for my lack of any sort of technical rigor. So let's talk real quick about why we visualize data. Hopefully, we have done some of this. We've seen sort of the benefits. But a lot of times when you ask people, well, why do you do this? It's sort of the answer is like, well, because it works? I don't know. Like, it's a little tough to actually quantify. So I think there's three main points of why we do this. The first is discovery. When we look at a piece of data, we can, especially if it's in a sort of tabular form, or it's in if it's not visualized, if we're just looking at a table and we're looking at the raw numbers, it can actually be really hard to sort of glean like what that means. It's hard to see signals, and so we do visualization in order to discover those signals. We start to look for minimums and maximums. We start to look for troughs in the data and those sorts of things. And we may not understand all the reasons why those are there, but we get a sense of the shape of the data. We start to understand kind of how it all fits together. And of course, the next step is then understanding. So what sort of correlations can we make? Why do we see certain patterns? Let's say we have users. Users behave in a certain way. And we can try to start to figure out what's driving that behavior, what's motivating that behavior. And then, of course, once we've done that, we can actually have decision making. We can actually take that data and we can do something with it. Right? We can say, okay, well, let's reinforce that behavior. Or maybe that's not the behavior we want. We want to try something new. Or we need to go look for, we have a problem, we need to go try to solve it. Let's go figure out why we have a problem. So I want to look at, real quick, a couple of visualizations that I think do this pretty well. So the first is of my hometown, Chattanooga. So, well, who here is from Kansas City, actually? So a good number. Who has Google Fiber? Who loves Google Fiber, right? It is awesome. Well, Kansas City, I'm sorry to tell you, Chattanooga, we've been doing fiber since before it was cool. We actually have the largest fiber rollout in the United States, humble brag. And my friend, Mary Helen, actually did a visualization of it. So the whole white area is actually the coverage area for our fiber internet. And then the adoption is all the colored areas. And you can actually see very visually now where coverage is. You could look at this on a graph or on just a table, but you wouldn't have an understanding of the sort of the spatial quantities about these places. You might not understand what these regions really mean, what these neighborhoods are. And so it would be really hard to actually look at just the numbers and glean this kind of understanding, right? And we can also start to ask questions about this, like why are there areas of higher adoption? What's driving that? What's motivating it? And how can we sort of lean into that? Why are there areas where there is no adoption? Have they not heard about fiber internet? Or, do they not see the benefit of it? We can start to ask these sorts of questions. So this is from the New York Times. They released a article about Facebook's IPO. And I don't know if you remember Facebook's IPO, but it was a very debated thing, right? It was, a whole bunch of contention about how large it was and just like the ramifications of that. And they kind of wanted to do a story on it, and they made part of that story was building this graph. You don't actually have to know any of the numbers here. And you'll notice that none of the numbers are actually shown, which is a topic we could talk about later. But all you get is a scale, and you get relative scale to the actual graph here. But just by looking at it, you don't have to know anything about these real prices, but you can get a sense of how far off, how much of an outlier the Facebook IPO actually was, just by looking at it, right? And then actually this graph is phenomenally, it's very interactive, and you can actually step through a couple different steps in it, and you can kind of get more, you can get a better understanding of everything. And then there's like this thing. This is not a humble brag, because I think this graph is like a graph of unhealthy work-life balance, probably. But this is GitHub's contribution graph, right? And this isn't mine anyway, so I'm not trying to be like, look at how much code I write. And the thing is like, what this is really showing you, what this is really telling you is really how often you do something on GitHub, right? Not actually how much work are you doing or whatever. But that's kind of the viewpoint it's giving. And you can just look at it and gain sort of an understanding of like, oh, look how awesome I'm doing. I've got all these green boxes. And some of them are darker, which means I worked really hard that day. So I think the point of all this, just to sort of emphasize here, is that is the power of stories. This is sort of the power of storytelling, right? We're painting a picture for people who will come after us, trying to look at this data and find reason in it, trying to sort of understand what's going on. Of course, there's a problem with this, with trying to tell stories in our data. And I want to sort of show you that problem by talking about something that maybe we can all understand, which is server responses. Right? We all understand server responses. We have a server, it gets a certain amount of requests, and it responds to them. And we want to track how long that is. So let's say for every 5 seconds, we get some amount of requests, and we want to look and see what that looks like. So we could very quickly just say, okay, well, let's just average them all. We'll make a graph of that, and it looks really great. And like, it's like right around 365 milliseconds. So I guess this is like Ruby or something. And so, this is working really great, and this looks great, and our server's doing good, right? The problem with this is a total fiction, right? We've completely lied to everybody else who's looking at this. Because, most people realize this. This is a little bit hand-wavy, but like most people realize showing averages like this is a fallacy. And if you actually look at the distribution of your requests, it probably looks something more like this. Right, which is that you have a whole bunch of very small requests, and then you have something that hovers, in a more reasonable 200 milliseconds. Then you have this really long tail. And this side over here, because it's like I mostly work with startups, so we call this the unicorn. And this down here is the real world, where you actually have real problems. And this is like standard 95th, 99th percentile stuff when you're trying to do optimizations. And if you actually readjust the scales and only look at things that are past the 2-second mark, you see we actually have several buckets where requests will take 3,000 milliseconds, so 3 seconds or 4 seconds. And all this is just to emphasize the fact that visualization is one viewpoint into your data, right? Whenever you make a visualization, you're giving one viewpoint into the data, right? To some degree, you're creating a sense of bias. Now, it's important to realize you're not biasing the data itself, but you are biasing how everyone else will look at and consume that data. And you're biasing their sort of methodology for trying to discover and find problems. And often this is unconscious. We don't mean to do this. We didn't set out to trick everybody else that came along after us. It just sort of happened. And I think this happens a lot. Like, how many of us have dashboards in our system that give us completely useless metrics that are not, they're like, probably they're really just a manager wanted to look at it. It's got pie charts on it, which that's your biggest red flag that it doesn't mean anything. The point of this is that visualizations tell stories. And if we actually stop and think about the stories that we're telling here, for instance, in this line graph, this is really something along the lines of like, this is how the server's doing, overall-ish. And in the case of our kind of our distribution, our histogram, we're talking about this is how our users are doing, right? We've just changed the story, and by changing the story, we can actually think about the kinds of visualizations that we want to do. So knowing that this is a problem, how do we solve it? Right? Which is hopefully why everybody's here today. So I think there's two things that we can do. The first is tools. Somebody said when you have D3, everything looks like a visualization. I mean, have you seen some of those D3 demos? They're awesome. But, you know, I think it's the tools themselves aren't super important. D3 is great. If you use something like R or MATLAB or any of these other tools, IPython notebooks, like you can use whatever you want. It doesn't really matter. But get used to your tool and get kind of comfortable with it and, you know, spend a lot of time with it. Specifically, I use JavaScript and I use D3, mostly because I know both of those things. And I can prototype really quickly. I can move really fast. And that means a lot to me. The really more important piece of this is process. And I think there's three kind of just key points here, which is just we want to keep it simple. We don't actually want to get fancy. All those fancy D3 graphs, those are awesome and probably great as an end product. But if we're trying to discover something, we don't want to jump into that. Because one, it'll take you too long and you'll get married to it and you don't want to throw it away. And two, you may hide some of the signal that you're trying to actually show. The second is just make it ugly. Like all the examples I'm going to show you today are all very ugly. And that's intentional. I don't want to bias myself with aesthetics. I don't want to say, well, this one looks nicer than the other one, so I'm going to use this one, right? Because again, that would be, we'd sort of be hiding, we'd be biasing the decision. And then consider the viewpoint, right? We need to consider what it is that we're actually demonstrating to people. So that's really easy to say and harder to do in practice. So I want to actually talk about a real example. This is a thing I really did. And I want to go through it and just kind of explain a little bit of the process. So I help organize a meetup in Chattanooga. We have, it's a weekly thing. We all get together on Thursday afternoons and we eat lunch together. We actually provide lunch for people. And we talk about something about technology, right? We'll have a discussion group. We'll do lightning talks, as is showed here. We'll talk about front-end stuff, JavaScript, whatever the hottest JavaScript framework of the day is. We'll talk about CSS. We'll talk about computer science theory. So, you know, somebody talked about Turing machines, quantum computing, all these sorts of things. And it's totally different. And every time we get sort of about 60 people, and they just, it's sort of kind of a rotating set. But I had noticed, I was looking at our data, and we try to be very data-driven when we run this meetup group. We actually do experiments. We actually keep track of that data, and we see how it affects the overall kind of feeling of our group. We see how it affects attendance, and we actually try to be very analytical about that. And I was looking at the data, and I sort of realized that our attendance was kind of all over the place. It was really starting to fluctuate really wildly. And I wanted to figure out why that was. So I did what any analytical person would theoretically do, and I created a hypothesis. Now, how many people remember how to make a hypothesis? Okay, couple. That's cool. This is great. We're gonna learn this. It's a pretty useful tool. There's two things that you need. The first is that you need to make an assertion, and the second is that you need to be testable, right? So I care about attendance in my meetup. I care about what it's doing long term. So let's make an assertion. Let's make a hypothesis about that. Let's try a couple times, make a hypothesis about that, and see how we do. So let's try. This is the first one. How do we get more people to come to our meetup? Who thinks this is a good hypothesis? Hopefully no one. Because this is neither an assertion nor is it testable in any way. I would love to know the answer to this question, but I can't actually verify this, right? So this isn't a good candidate. So let's try again. Attendees only come to talks that are relevant to their job. So this is better. It is an assertion now. The problem is I can't test this because I don't actually have job data for anybody. So, and if I tried to kind of come up with it ad hoc, it would be biasing, and I want to mess with any of that. So let's try one more time. We'll just say very loosely, topics are correlated to attendance. And what I really mean by this is topics drive attendance, right? So the topic of the talk drives attendance. So I can look at that. I can look at how I'm going to do that, and I want to think just in this process. This is how I was starting. I just start very, very broad, and I say, let's get a shape of the data. Let's like understand what's actually going on. So the very first thing I want to do is just look at attendance over time. So attendance over time is one value, which is changing, right? And in this case, over time, but it could be whatever. Turns out there's a really easy graph that will just sort of showcase that, and it's called a line graph. It's not very complicated. And if we build a line graph of that, this is like what our actual attendance looked like. And you can see that there's some pretty interesting clear signals here, right? We get some pretty big peaks and some pretty low troughs. And we can start to see that we get, these are sort of maxima, and these are sort of minima, and local maxima and local minima. And this is really interesting, right? Because this sort of validates, this already sort of gives me some validation about what I had been seeing anecdotally, right? I was sort of noticing this, and the data kind of helps back that up for me. But of course, we care about topics here. We don't just care about the data itself. So real quickly, let's just try to, again, get a good sense of what's going on here, and let's just add some colors. So I want to make a slight note about color. Color is really tricky, and you shouldn't necessarily just default to relying on color when you're doing visualizations. I am here mostly because I hope it shows up well, and also because I was doing this on my own, and I understood. I was, kind of let D3 pick the colors for me and that kind of stuff. But color theory is actually fairly complicated, and colors can have a lot of like emotional attachment to them. And on top of that, if you're actually giving this out to other users, not everybody can see the colors that you see, and now you have an accessibility problem. So just like maybe think through maybe think through that if you're doing this kind of stuff for a large amount of people. But that being the case, I did use color in this, so oops. You can see that we can start to look at our maximums again. I think that's a good place to start. And we can actually see, we'll pick a topic like front end, right? And we see that in general, a lot of the front end talks, but not always, tend to be sort of either at a local maximum or at least trending in that direction, right? And now whether or not that trend is meaningful, we don't know yet. But suffice it to say, a lot of them are, though not all. There's a couple down there towards the end, and there's one over here kind of in the middle. So there's definitely some outliers. Well, if we compare that to something like technology, which is another just topic that we have, which is basically a catch-all of just random stuff, we can see that a lot of these sort of trend lower, right? They're sort of like fixated around local minimums, although again, not all. So this is really important because what we've done here is we've just sort of started getting a sense of this. We can kind of see that maybe there's correlation between topics. And it would be real easy at this point to sort of go, well, it looks like technology, no one cares, and we'll never do technology talks again. That would be a conclusion you could draw. But it's important to step back and realize what story we're telling. We're trying to look at users' attendance, right? And what we're looking at right now is actually just attendance in general, loosely correlated with the topic. And so if we're caring about users' attendance, the actual users themselves, when are they showing up? What are they actually going to? Well, again, going back to our server problem, this would lead you to realize that what we're really talking about here is a distribution. When you have a distribution, there's another really great graph that's useful, and it's called a bar graph. And it's not very complicated. And if you actually in this case, I'm going to create a stacked bar, but we can create something like this. And it's a little bit cut off towards the right there. But you can see this is now users along the bottom, and then sort of normalized attendance. And we can see, we get this really pretty, it's nice, and this is kind of, again, the danger of color. It's a very pretty graph. But we see this giant mishmash of color, right? So how can we actually discern anything from this? Well, the first thing that immediately jumps out to me is that we really have a couple different sets of people here, right? In fact, this grouping towards the end here, I'm going to call them Team Pizza, because they show up no matter what, assumably to get pizza, and maybe to talk about technology, and realistically probably to hang out with their friends. And then you have this group down here, which is like the long tail, right? You have the people who sort of come to maybe one or two talks, maybe not a lot, and never really of the same category. And so in order to do any sort of real analysis of this, we'd have to actually look at each individual user and try to cater to them and try to understand what it is that we're providing to them. I think this is really interesting. And from this graph, we can start to see that there are certain trends. We can see this purple line goes far down into the tail, right? We start to see the blue line start to go down into the tail, but really, this is sort of a mishmash of things. And I think we took this information, we went away, we took our hypothesis that said, okay, well, topics are correlated to attendance, and then we actually just validated it, right? It seems like this, based on this chart, we aren't actually seeing any sort of real trends here. We're not seeing what we think we're seeing. And in fact, what it really seems like is that people just sort of come to whatever. And probably a more meaningful metric is who's giving the talk, or what are we having for lunch that day, or are their friends going? So our hypothesis of topics are correlated to attendance, well, not really. And we actually went away and validated it. We sent an email poll out to everybody, and we said, hey, why do you come to lunch? And it turns out that most people show up because they're friends, which was interesting, right? And so I went away, and I created another graph. So this is every talk we've given over the past year or 2 years. It's a lot of talks. It's more than a year. It's obviously more than a year. And then that's every user. And you can start to see these striations, which is interesting because what this actually becomes, we didn't know what this was at first, but when we actually looked at this, we realized, and we figured out the groupings that we needed. What we actually realized was those are companies and friend groups all joining at the same time, right? And down here at the bottom, you have this line is basically the line of when you joined. And you can see the lines when you get these horizontal lines. Well, that's like friend groups all showing up together to a talk. And you can get a real sense now that maybe a motivator is not a topic at all, but it's just who you're coming with. And so from an organizer's perspective, we can actually make a decision about this. Where the decision would probably be something like, how do we get that first person to show up so they can bring all their friends? But again, that's sort of, once you have this understanding, you can actually make those sorts of decisions. And the thing is this took me, I think, around 2 to 3 hours to come up with, right? Because you just sort of iterate. You sort of take the knowledge that you're getting, and you start to figure out what new kinds of questions you can ask of your data. How can you expound on what you have? So that's about all I have, really. But I want to kind of sum up and just leave you with a few points, which is the first thing I just think you should always do is just consider your story. Consider the story you're telling to people, right? Because it's like as Uncle Ben said, with great power comes great responsibility. We have this great power when we're actually providing these visuals for people. And we can influence people in ways that we don't mean. And so we should always consider the stories that we're telling because we want to be transparent. We want to give people a real viewpoint into what we're looking at. Once you've done that, then you can choose the visualization that you want. Don't go to D3 examples and then pick the one that you think looks cool. Actually build something that's going to be useful for your audience. And then finally iterate. If you don't have a story, or if the story you're looking at isn't that interesting, or if it's boring, well, maybe that's okay. Or maybe you've discovered some new insight. So you can build something new, and you can start to provide new benefit. And finally, I think the most important thing is question your biases. Right? Question what it is that you're bringing to the table when you actually do these sorts of visualizations, when you look at them. And make sure that you're actually showing that you're telling the story that you want to tell. So, thank you. Definitely have time for questions if anybody has a question. I have other stuff I can show too. So, if you just want to like look at cool graphs. Okay. So let's see here. These are like all failed attempts and stuff. This is the most recent. Okay, so this is a pretty great story. All right. I got you. All right, so this was a really fun project. This was early in the year. We were actually working for a company that was building biometric sensors and basically using them at parties and at meaning like concerts and also at like sporting events. And what it would do is you could actually track sort of these like things like galvanic skin response and acceleration, ambient noise, all these sorts of metrics that then they like attached different cute names to. And you could actually give this data, you could process it in real time and then show it to somebody, like for instance, the DJ or like the actual person like kind of putting the venue on. So you could kind of get a sense of like the emotions of the crowd. And we built this thing, and I think it was in a week. No one thought the project was going to work correctly. We kind of got brought into it last minute because we had some experience doing data viz and also doing real-time processing. And so we did it, and after the fact, it was kind of told to us that like the guy doing the concert didn't really feel like he got the kind of feedback he was wanting to get from it. And we were kind of trying to figure out why. So we graphed all this data, and we looked at each of the three emotions, and we kind of correlated it to the songs. And we were trying to find signals that were meaningful here. And you can tell the data is super noisy, and it's really hard to find a meaningful signal in all this. And so we sort of stepped back, and we realized, like, okay, so we're tracking these emotions and the change over time, or excuse me, these sort of metrics and the changes over time. How can we look at this differently? What actually went wrong here? And when we did that, we realized we should probably look at this from the point of view of the user, right? So obviously, like if you have users, let's track users and then see how they change over time. And that was, that culminated in this graph, where every row here is a user. And I don't know if you can tell, but these big chunks right here where there's nothing, that's bad. Because that's where we have no data. And it turns out there's this funny thing about 0MQ where if you don't pass it the right flag, it like throws things on the ground without error after it like buffers a certain amount. Anyway, but the point of this is we weren't getting data. And like we had to go, we never would have seen that. We never ever would have seen that based on that previous example. But we could see it when we actually rethought our problem. And then, of course, the decision-making process is like, well, why? This is not good. Turns out, don't flood a Bluetooth network with like 20 hubs trying to connect it. Anyway, it's bad. So, that's a pretty. And there's a whole bunch of that. Like most data viz stuff, like boils down to problems like that, where you're just looking at it wrong. Of course, a data scientist would be like, well, if you'd just done the math, then you would know what visualization you needed to use. Any questions? Any other questions? Yeah. Oh, I think there's a mic coming. Sorry.
I should know. How do you advise we make better decisions about which analysis to run, like which data to look at? How do we make the best decisions?
Yeah, that's a great question. That's a fantastic question, actually. So that's really hard, right? Especially if you're coming into a new domain where you don't actually understand anything about it, or even if you're slightly familiar with the domain, there's probably nuances to it about with that specific business and the way that they've divided up that domain. I think the best thing to do, one, is just to start exploring. Is just to start trying things. And that's kind of what I was doing with that line graph, right? It's like, this is a known quantity. This is something I can actually very easily look at and then start to get an intuitive sense of what's going on. I think starting there and then just being flexible and iterating and continue to like seek out new intuition and just try to discover new things, that's going to be your best bet. And that's typically my process when I'm on a client project doing this kind of stuff.
Yeah, I think it's somewhat of a similar question, but I was going to ask you where you get like kind of your inspiration for a lot of stuff. You know, I pay attention to what's Bostock, Mike Bostock.
Yeah.
His D3 stuff is amazing, but you know, just always trying to. I'm at a company, and you know, new ideas, new ways of presenting data. Where you know you turn to for that kind of stuff.
I don't know. That's a great question. I mean, definitely. I mean, as much as I like rag on like don't pick D3 examples, like D3 examples actually are pretty useful. But I think they're useful in as much as they sort of expand your adjacent possible. They sort of tell you like ways that you could look at data. Mostly, I think stick to tried and true practices. Stick to Tufte. Like basically take everything Tufte's ever said as the Bible. Like I think that's actually you're in really safe waters when you do that. You know, remove chart junk and all that kind of stuff. And you know, but like you can often get away with like really simple stuff at first, and then when you need to do something complex, well, then maybe you have to think through the problem, look for examples and that kind of stuff. But yeah, most of it's just I like pay attention to whatever Bostock's doing, and yeah, all of Tufte's books. Which, if you're not familiar with Tufte, you should totally go read all of Tufte's books. They're phenomenal and they're beautiful. Like just go look through them. They're absolutely gorgeous. So yeah.
What sort of technologies do you use for logging data and then querying it?
Oh, that's also a great question. So typically whatever we have on hand, like sometimes you're walking into a client project and they have a database with this stuff and that you need to ETL out of there, right? So that's the first thing is like, get the data out, don't run stuff like this on like production. that would be bad. Like have a reporting database. I typically do either if I need the data, if I can get it out of a REST endpoint, I'll do that. If I need to go write a query, whatever. And then typically I just like store it as JSON because it's faster to just loop over it and do it all in JavaScript and transform it. Basically like Lodash all the things. So, any other questions? Yeah. Oh, yeah.
Yeah, you talked a little bit about eliminating your biases, and I wonder if you can maybe expound on that a little bit more, especially with regard to the ethical implications of oversimplifying your data for the purpose of visualization. And if, like you in your own biases kind of coming out as like lying about your data, or you're casting a story in a way you want to say it when the full data set maybe doesn't support that. You know, like how does one fight against bias that way?
Yeah, that's incredibly difficult because often you want there to be a story, right? Often you go looking for these things, kind of wanting them to be true, and I think you have to. It takes a lot of practice just to realize it's a hypothesis, to realize it's going to be valid, like it's either going to be valid or going to be invalid. And there's definitely lots of like little tricks that people pull, like they switch axes and they switch scales and all that kind of stuff. I think it takes sort of constant vigilance. It helps to pair with people. Like I typically will do a viz, and then especially for like the stuff I was doing with our Meetup group, I sent it to everybody pretty much as I did it. And said, what do you see in this? You know, and you try to get solicit feedback and have people check you on it. Yeah, you need a good support group, I guess. So other than that, it's just really question like if you care a lot about seeing a story and you're disappointed that it's not showing up, well, you probably have some sort of bias there. So that kind of thing. Anything else? All right, cool. Well, thanks, y'all.